You get great soft tissue contrast in MRI because all tissues within the body relax at different rates. So let's take a look at two tissues that are on the opposite ends of the spectrum in terms of the molecular makeup. First, you have fat. Over here you can see it's a very large molecule with a combination of carbon and hydrogen bonds, where this is a very closely packed molecule. So if you put it in a beaker, you can see that these molecules will be butting up right against each other. That means that you're going to get more spin-spin interactions, which will cause quicker dephasing. Fat also has a slower tumbling rate, which means it's going to give more energy off to the surrounding tissues or the lattice. It's also non-polar because the hydrogen do not steal the electrons away from carbon, so this means it's going to be less available to the effects of the static magnetic field, which in turn means it's going to process slower. All in all, this means that fat has an efficient energy exchange with the lattice and the neighboring spins, which results in a rapid T1 recovery and T2 decay. Now let's compare that to water, or a water molecule. You can see that the water molecules are further spaced apart when you put it in a beaker. It is a liquid, so these molecules are further spaced apart. That means you're going to have less spin-spin interactions, which results in less dephasing of those molecules. Water also has a faster tumbling rate, which means it's going to give off less energy to the surrounding lattice or surrounding tissues. Water is polar because the hydrogen steal the electrons away from the oxygen atom, meaning that the hydrogen within water are more available to the effects of the static magnetic field, which makes it process faster. All in all, water has an inefficient energy exchange with the lattice and surrounding spins, which results in a slower T1 recovery and T2 decay times. So here you have the two diagrams showing T1 recovery, also called spin lattice, and T2 decay, which is also called spin-spin. As a reminder, for the T1 recovery curve, the y-axis is labeled longitudinal magnetization, and the x-axis is labeled time in milliseconds. And you can see that fat, as it gives off energy to the lattice, will recover faster than water. And you can see at 63%, when the tissues are considered fully recovered, you have the T1 time of fat occurring quicker than water. Over here you have your T2 decay curve, where on the y-axis you have transverse magnetization, and on the x-axis, once again, you have time in milliseconds. A tissue is considered fully decayed when it only has 37% of transverse magnetization left, and you can see that fat, being a very tightly packed molecule, will have more spin-spin interactions. It will dephase a lot quicker than water, which is further spaced apart. So the T2 time for fat occurs sooner than water.